Welcome to Algorithm Sense channel. In this video, we'll talk about a compact equation which describes a three-dimensional well-known object. Stay tuned for exploring this equation. Absolute of x plus absolute of y plus absolute of z equals 1. This equation describes the surfaces of a regular octahedron which consists of 8 faces, each face is equilateral triangle. How does one equation describe 8 surfaces? The absolute function can be decomposed into two bases. The first base is the positive value of the absolute argument, whereas the second base is the negative value of the absolute argument. The range of each base can be determined by applying the absolute function condition, plus or minus the absolute argument must be greater than 0. As for our equation here, two bases is generated from each absolute term. By applying the absolute condition, the first base is the positive value of the argument, and its range x is greater than 0. The second base is the negative value of the argument, and its range x is less than 0. We have three absolute terms, each term has two possibilities, so we can get 8 combinations. When x is the positive base, y may be chosen to be the positive base or the negative base. Also, if x is the negative base, y may be chosen to be the positive base or the negative base. Now we have 4 possibilities: positive x with positive y, positive x with negative y, negative x with positive y, and negative x with negative y. Finally, z may be positive or negative. Each possibility for z corresponds 4 possibilities to x and y pair, so we have 8 equations. Each equation represents a planar surface since x, y, and z do not contain fractional exponents or higher order powers. The power of either x or y and z is 1. The first equation, positive x plus y plus z equals 1, which is located on the octant x, y, and z are greater than 0. The simplest method to sketch the planar surface is to find 3 points achieve the surface equation but are not located on one straightness. The surface borders are determined by the conditions on x, y, and z. The first point is obtained by putting both x and y equal to 0 and solving the equation for z. It gives z equals to 1. In a similar manner, when both x and z are equated to 0, y becomes 1. When both y and z are equated to 0, x becomes 1. The surface is known by 3 points, p1, 1, 0, 0, which lies on positive x-axis, p2, 0, 1, 0, which lies on positive y-axis, and p3, 0, 0, 1, which lies on positive z-axis. By connecting a line between each 2 points, the surface shape is an equilateral triangle. Note that the lines must not exceed the range of the first octant, which means the surface area is limited to the equilateral triangle only. Following the same procedure, the other 7 equations can be drawn considering the range of each octant. The points of the second octant, x, y are greater than 0 and z less than 0, are p1, p2, and p4, 0, 0, negative 1. The points of the third octant, x, z are greater than 0 and y less than 0, are p1, p3, and p5, 0, negative 1, 0. The points of the fourth octant, y, z are less than 0 and x greater than 0, are p1, p4, and p5. The points of the fifth octant, y, z are greater than 0 and x less than 0, are p2, p3, and p6, negative 1, 0, 0. The points of the sixth octant, x, z are less than 0 and y greater than 0, are p2, p4, and p6. The points of the seventh octant, x, y are less than 0 and z greater than 0, are p3, p5, and p6. The points of the eighth octant, x, y, and z are less than 0, are P4, P5, and P6. Here's the 8 surfaces which are described by the equation absolute of x plus absolute of y plus absolute of z equals 1. They form the surfaces of a regular octahedron shape as depicted. The projections of this equation in the principal planes are squares with diagonal length is 2 and the edge length equals to square root of 2. But, what about the volume surrounded by the octahedron surfaces? The total volume of the octahedron can be obtained using the volume relation of the pyramid. It is the double of the pyramid volume, which is given by 1/3 multiplied by pyramid base area multiplied by pyramid height. The pyramid base is a square with length square root of 2, so its area A equals to 2. The pyramid height h equals to 1, so the octahedron volume equals to 4 divided by 3. The surface area of the octahedron is calculated by multiplying faces number by the face area. The octahedron faces are equilateral triangles. The edge length of each triangle equals square root of 2, so the triangle area equals square root of 3 divided by 2. The total surface area of the octahedron equals to 4 multiplied by square root of 3. Thank you for watching. Please support us continuing these videos by sharing them, subscribe to our channel, add comment and give us your feedback, like or dislike. Thank you.